Welcome, dear friends. You've arrived at a place where sleep becomes knowledge, where a gentle voice guides you through the silence of night. Tonight, we lift our eyes to the heavens, to a star named Sun that has pulsed for billions of years, to planets waltzing in cosmic dance, to a void that isn't empty at all, but a magnificent canvas where time paints galaxies, meteors, and celestial light. Close your eyes. Imagine yourself floating through space, weightless, like a drop of light. Around you, cold and silence. But somewhere in the distance shines our home, the sun. We're embarking on a journey through the solar system. We'll peer into its heart, witness fiery Venus, study Earth and Moon, fly over Jupiter's storms and Saturn's rings, reach the icy frontiers, and touch mysterious comets. Before we begin, if you enjoy these slow nocturnal journeys through worlds past and future, don't forget to subscribe. By the end of this lecture, you'll be sleeping soundly. It helps our channel shine brighter, like a new star on the horizon, and you'll always know where to return when you crave peace and meaning. Now wrap yourself in a blanket, close your eyes, release the worries of the day, and let my voice guide you through the night's silence, far to the stars and to the very essence. We begin. The solar system, an island of life. The solar system is an island of life amid the icy ocean of space. It seems tiny by universal standards, but if you imagine the sun as a soccer ball, Earth would be the size of a pinhead, rotating 25 meters away. And even at that scale, the nearest star would be over 7,000 kilometers distant. Birth of the solar system. The system is approximately 4.6 billion years old. If we compress that time into a single day, humanity appeared only in the last 2 minutes before midnight. We are infants by stellar family standards. The system arose from a gigantic cloud of gas and dust, a fog spanning trillions of kilometers. At some point, the balance of this cloud was disrupted, possibly by a nearby supernova explosion. An energy wave passed through the cloud, and under gravity's pull, it began to contract and rotate. In the center, the sun ignited, a dense, hot, flaming core of hydrogen and helium. Around it remained a rotating disk of dust, like a thin pancake. From its particles, very slowly, planets, comets, and moons were born. This was a natural process, but with a surprisingly harmonious result. Orbits stabilized, planets spread out by distance. Some retained gases, others became solid bodies. An architecture emerged that we still study today. What does system mean? This isn't just a collection of bodies flying through emptiness. It's an ordered, gravitationally bound structure. The sun in the center acts as conductor, the planets as orchestra. Each plays its line in a grand cosmic composition. Orbits are calibrated, stable. The system lives in rhythm, slowly rotating around the center of our galaxy. Inner bodies are closer to light, rocky, dense, heated. Outer ones are icy, gravitationally mighty, far beyond the reach of solar warmth. Between them, asteroids, moons, comets, and invisible interplanetary dust that we don't notice, but without which this mechanism would be different. Two worlds, inner and outer planets. Today, all planets of the solar system can be conditionally divided into two realms, inner and outer. This isn't just positioning. These are two different types of planets by composition, structure, and birth. Inner planets are those closer to the sun: Mercury, Venus, Earth, and Mars. They're called terrestrial planets, comparatively small, dense, with solid surfaces. Their atmospheres are thin or absent entirely. Why? Because at birth, they found themselves too close to the sun, and its heat simply didn't allow them to retain light gases. They're like scorched stones by a campfire, burned, dense, weathered. Beyond them, far past the asteroid belt, begin the outer planets: Jupiter, Saturn, Uranus, and Neptune. They're called gas and ice giants. They're far more massive than terrestrial worlds, but consist mainly not of rock, but of gas: hydrogen, helium, methane. They have no solid surface, only dense clouds and possibly hidden cores. Their atmospheres are deep and turbulent, their rings complex and varied, their moons separate worlds. Our galactic address. To understand our cosmic address, imagine our galaxy, a huge rotating disk with curved arms, like a giant shell studded with stars. This is the Milky Way, home to up to 400 billion stars. Our solar system isn't located at the center or edge, but on one of its arms, the Orion arm. It's like being in a suburb of a great metropolis, not too noisy, not too crowded, the perfect place to live. We're located approximately 27,000 light-years from the galactic center and, together with the entire system, fly in orbit around the galactic nucleus at a speed of about 800,000 km/h. One such circuit takes about 230 million years. Everything you know, human history, dinosaurs, Earth's appearance, happened in just 1/20th of a rotation. We're newcomers to this motion. What makes our system special? The solar system is remarkably stable. Planets don't collide. Orbits are nearly circular. The sun, a medium-mass star, isn't too hot, not too bright, but stable. It doesn't explode, doesn't fade, doesn't fluctuate. On the third orbit from it, Earth. Here, everything converged to create oceans, atmosphere, breath, consciousness. There's also the moon, our constant companion. Jupiter, a giant that deflects dangerous bodies, and a magnetic field that protects us from solar wind. You can call this coincidence, or you can call it nature's design. But the fact is that here, in this system, a creature appeared capable of looking back and asking, where do we come from? The sun, heart of our system. When we say sun, it seems we know it. We see it every day outside the window, on the horizon, in water's reflection. But this is only an image, only light breaking through the atmosphere. The sun itself isn't a circle in the sky. It's a star, enormous, ancient, continuously burning. It's unlike anything we encounter on Earth, a fiery ball of plasma, heated to millions of degrees at the center, with a surface that boils and ejects matter into space at hurricane speeds. Yet it gives us life. It shines just enough. It warms but doesn't burn. It doesn't fade. It doesn't explode. Composition and structure. The sun is not flame. It's a main sequence star, meaning a star in the stable phase of its life. Inside, there's no burning fire. Nuclear reactions occur. Approximately 75% of the sun's mass is hydrogen, about 24% helium, and the rest is oxygen, carbon, neon, iron, and other elements. Its diameter is nearly 1.4 million kilometers, more than 109 Earths lined up. But the most incredible thing, the sun contains 99.86% of all mass in the solar system. Everything else, planets, moons, asteroids, is a pitiful fraction of a percent. We orbit a giant. How the sun works. At the very center of the sun, in its core, temperature reaches 15 million degrees. Pressure is so enormous that hydrogen nuclei fuse to form helium. This is thermonuclear fusion, a process where part of mass converts into energy. This mass-to-energy conversion explains Einstein's formula, E=mc². Every second, the sun loses 4 million tons of matter, but it doesn't disappear because it's enormous. Energy born in the core struggles toward the surface for hundreds of thousands of years, bouncing off particles like light through fog. Then, In 8 minutes, it reaches Earth. And there it is, sunlight. It falls on your windowsill. It feeds leaves. It drives weather. It reflects in your eyes. All of this began deep inside the star, the sun's layers. The sun is not uniform. In the core, energy is born. Above is the radiation zone, where energy is transmitted as light. Then, the convection zone, where matter churns like boiling soup. Above that is the photosphere, the surface we see. Its temperature is about 5,500 degrees, nearly white, but appears yellow to us due to our atmosphere. Higher still is the chromosphere, a thin layer. And finally, the corona, the sun's outer atmosphere, visible during total solar eclipses. Temperature there, unexpectedly, reaches millions of degrees. Why it's hotter than the surface remains one of astrophysics' mysteries. Solar wind and activity. The sun doesn't just shine, it ejects particles, streams of plasma that fly in all directions. This is called solar wind. Sometimes flares occur, sudden bursts of energy and matter. If they reach Earth, they can cause auroras, satellite disruptions, and even power grid failures. But fortunately, Earth is protected. We have a magnetic field that deflects most particles. We literally exist inside a giant bubble of solar wind, the heliosphere. This is the sun's influence boundary, extending approximately 120-150 astronomical units beyond Pluto's orbit. The Voyager probes crossed it. The sun's future. How much longer will the sun shine? Currently, the sun is in a stable phase. It's already lived roughly half its life. It has about another 5 billion years before this stage ends. Then it will begin expanding, transforming into a red giant, engulfing Mercury, possibly Venus, and even approaching Earth's orbit. Then it will shed its outer shells, leaving behind a white dwarf, a tiny, dense, cold remnant, the heart of a dead star. But that's billions of years away. For now, the sun is stable, and every morning when it rises, it reminds us, life continues. Mercury, the swift messenger. We approach the first planet from the sun, the fastest, closest, quietest. This is Mercury, a planet easy to miss from Earth. It's too close to the sun, hiding in its brilliance. It's difficult to see even through a telescope. Yet it's one of the most ancient stones in our system's mosaic. Mercury's outer shell, or crust, is very thin, about 20 kilometers. Its surface is covered with craters formed from intense bombardment by asteroids and meteorites in the early years of the solar system's existence. One of the most impressive craters is Caloris, with a diameter exceeding 1,300 kilometers. It's so huge that the impact creating it caused chaotic terrain changes on the opposite side of the planet. Study of Mercury began with the Mariner 10 mission in the 1970s. This spacecraft transmitted the first detailed surface photos and discovered the existence of a magnetic field. But the real revolution in understanding Mercury was produced by the Messenger mission, which entered the planet's orbit in the 2000s. It collected data on surface composition, measured the magnetic field, and revealed numerous geological features. Mercury is a window into the solar system's past. Its surface has remained virtually unchanged for billions of years, preserving traces of early planetary formation processes. Its unusual structure and motion give scientists keys to understanding gravitational interactions, stellar influences on close planets, and processes of planetary core cooling. Venus, the infernal twin. Venus is the second planet from the Sun and Earth's nearest neighbor, surprisingly similar to our planet in size and mass. It's often called Earth's sister, but the resemblance ends with the numbers. Venus is a true cosmic hell, where unbearable heat reigns, acidic clouds swirl, and atmospheric pressure could crush any Earth apparatus within minutes. Physical characteristics. Venus is indeed similar to Earth in numbers. Its diameter is about 12,000 kilometers, only 5% smaller than Earth's diameter. The planet's mass is approximately 82% of our planet's mass, and density and gravity are also close. If you stood on its surface, you'd weigh almost as much as on Earth. Venus is located approximately 0.72 astronomical units from the Sun, equivalent to 108 million kilometers. This is closer than Earth, but not enough to explain its incredibly high temperatures. The reason for Venus's catastrophic conditions is its unique atmosphere. The hellish atmosphere. Venus's atmosphere is one of the most extreme in the solar system. It consists of 96% carbon dioxide with small amounts of nitrogen and traces of sulfur compounds. Upper atmospheric layers are covered with dense clouds of sulfuric acid that don't allow sunlight through. Because of this, Venus appears so bright and shining in the night sky. Its clouds reflect up to 70% of solar radiation. On the planet's surface beneath these clouds, a real nightmare occurs. Atmospheric pressure on Venus is 92 times higher than on Earth. This is equivalent to pressure you'd experience diving 1 kilometer underwater. If we tried building a base there, it would be crushed instantly. Surface temperature and greenhouse effect. Venus's surface is the hottest among all solar system planets, with temperature reaching 470 degrees. This is hotter than Mercury, though Venus is farther from the Sun. The main reason for such temperatures is a runaway greenhouse effect that completely changed the planet's atmosphere and climate. Once in the past, Venus probably had conditions closer to Earth's. Perhaps liquid water even existed on its surface. However, proximity to the Sun played a key role in the planet's catastrophic transformation. Due to high solar radiation levels, temperature began rising, water evaporated, and vapor, as a powerful greenhouse gas, intensified the heat-trapping effect. Surface features. Under Venus's dense atmosphere hides an amazing world. The planet's surface has been studied using radar, since ordinary optical methods show nothing due to clouds. Venus is a planet of volcanoes. Its surface is almost entirely covered with lava plains formed by past eruptions. One of the planet's highest points is Maxwell Montes, rising to a height of about 11 kilometers, higher than Mount Everest on Earth. But most of Venus's surface is flat and marked with strange geological formations like corona, huge rounded structures formed by magmatic activity. Atmospheric dynamics. At an altitude of about 60 kilometers above the planet's surface, blow incredibly powerful winds with speeds up to 360 km/h. This phenomenon is called superrotation. The atmosphere rotates around the planet much faster than its surface. Venus itself makes one rotation around its axis in 243 Earth days, the slowest day among all planets. But a year on Venus lasts only 225 days. Thus, a day on Venus is longer than its year. Earth, the blue oasis. The main thing distinguishing Earth among other planets is liquid water. About 70% of our planet's surface is covered by oceans, seas, and rivers. Water is the basis of life, and its unique properties, such as high heat capacity and ability to dissolve substances, make it ideal for supporting biological processes. The habitable zone. Why does Earth have liquid water while, for example, Venus and Mars don't? The secret lies in the planet's location. Earth is situated in the so-called habitable zone, an area around a star where temperature allows water to exist in liquid state. If Earth were slightly closer to the Sun, it could have repeated Venus's fate. If it were farther, it would have become a cold desert like Mars. Magnetic shield. No less important is the magnetosphere, a magnetic field protecting our planet from solar wind and cosmic radiation. The magnetosphere is created by movement of the liquid iron core inside Earth and acts as an invisible shield. Without it, solar wind could destroy our planet's atmosphere, as happened with Mars. Plate tectonics Earth is a dynamic planet, and its surface constantly changes thanks to plate tectonics. Earth's crust is divided into several large and small tectonic plates that float on the liquid layer of Earth's mantle. These plates move, collide, diverge, and slide under each other, creating mountains, ocean trenches, and earthquakes. Plate tectonics plays a key role in the planet's substance circulation. For example, carbon dioxide released by volcanoes helps maintain the greenhouse effect necessary for preserving heat. Additionally, plate movement promotes Earth's crust renewal, maintaining the planet's long-term stability. Atmospheric composition. Earth's atmosphere is another unique feature. Its composition is ideally suited for supporting life. Main components are nitrogen, about 78%, oxygen, about 21%, and small amounts of carbon dioxide, argon, and other gases. This balance isn't accidental. It formed thanks to billions of years of biological and geological processes. Oxygen appeared in the atmosphere thanks to ancient microbes that began producing it through photosynthesis. This process, known as the oxygen catastrophe, occurred about 2.5 billion years ago and changed the planet's chemical composition, making it suitable for complex life. The Moon, our constant companion. The Moon is more than just a beautiful object in the night sky. It plays a crucial role in Earth's stability and life development. The Moon's diameter is about 3,470 kilometers, making it the largest satellite in proportion to its planet in the solar system. First, the Moon stabilizes Earth's axial tilt. Thanks to this, the tilt remains relatively constant, ensuring stable seasons and climate. Without the Moon, Earth's axis could wobble much more strongly, causing chaotic climate changes. Second, the Moon causes tides. These cyclical water movements in oceans, seas, and rivers not only affect coastal ecosystems, but also played an important role in life's evolution. Scientists suggest tides may have facilitated life's emergence on land, providing organisms an environment for adapting to various conditions. Third, the Moon served as a cosmic shield for Earth, absorbing asteroid and meteorite impacts in the solar system's early history. Without it, our planet's surface could have been far more cratered. Mars, the red planet. Mars is a planet that has attracted humanity's attention since ancient times. Its reddish color in the night sky inspired myths and associations with war and destruction. But nowadays, Mars symbolizes not war, but hope. It has become for us a window into the solar system's past and possibly humanity's future. Physical characteristics. Mars is the fourth planet from the Sun, located at an average distance of 228 million kilometers, equivalent to approximately 1.52 astronomical units. This makes it almost 1.5 times farther from the Sun than Earth. Because of this, Mars receives much less heat and sunlight. In size, Mars is approximately half Earth's size, and surface area is comparable to all of our planet's land territory. Mars's mass is only 11% of Earth's mass, and gravity on its surface is about 38% of Earth's. This means if you weigh 70 kilos on Earth, on Mars you'd weigh only 26 kilos. Climate and atmosphere. Mars is a true frozen desert. Average temperature on the planet is 63 degrees high, but depending on season and location, it can vary from 125 degrees at the poles in winter to plumb 120 degrees at the equator in summer. Such sharp fluctuations are related to the thin atmosphere, which practically doesn't retain heat. Mars's atmosphere is so rarefied that its pressure is only 0.6% of Earth's. This is equivalent to conditions at an altitude of 30 kilometers above Earth's surface, 3 times higher than commercial aircraft fly. It consists of 96% carbon dioxide with small admixtures of nitrogen, argon, and traces of oxygen and water. Dust storms. One of Mars's most impressive features is its dust storms, which can encompass the entire planet. These storms lift fine dust into the atmosphere, blocking sunlight and making Mars even colder. The largest recorded storm in 2018 lasted several months and led to the cessation of the Opportunity rover's operation. Surface features. Mars's surface is something incredible. Red wastelands of oxidized iron, enormous volcanoes, ancient dried riverbeds, and ice caps at the poles tell the story of a planet that once could have been completely different. Imagine Olympus Mons, the tallest volcano in the solar system, 22 kilometers high. That's 3 times higher than Everest, and its base is so enormous you couldn't see its summit standing at its foot. Or look at Valles Marineris, a huge network of canyons 4,000 kilometer long and up to 7 kilometer deep. It's 10 times longer than the Grand Canyon and 4 times deeper. Scientists believe these structures could have been formed by tectonic processes and possibly by water flows that once coursed through Mars. Water on Mars. Yes, water is the key to Mars's mystery. Today there's no liquid water on its surface, but we see evidence of its presence everywhere in the past. Billions of years ago, Mars was warmer and its atmosphere denser. Rivers flowed here, lakes formed, and perhaps an ocean existed covering a significant part of the surface. Now water on Mars exists only in ice form, in polar caps, or beneath the surface. However, there's speculation that beneath the frozen soil layer, underground lakes of liquid water may hide, especially in the South Pole region. These findings give hope that life could have existed on Mars in the past, and perhaps hides there even now. Mars exploration today. Mars is the main target for space exploration. Rovers like Curiosity and Perseverance continue exploring its surface, collecting data on climate, soil composition, and traces of ancient life. Curiosity, operating since 2012, confirmed that Mars was once habitable, and Perseverance, which arrived in 2020, studies Jezero Crater, the site of an ancient lake and river delta where microbial life could have thrived. But our ambitions don't end there. Elon Musk and his company SpaceX dream of sending people to Mars by the 2030s to begin creating the first settlements there. Jupiter, king of planets. Our journey continues, and now we leave the zone of rocky planets, heading to where giants reign. Between Mars and Jupiter stretches the asteroid belt, an area filled with millions of rocky and metallic objects that never managed to gather into a full planet. Scientists believe Jupiter's gravity prevented this, the most massive object in our system after the Sun. Physical characteristics. Jupiter is so large it could contain more than 1/300 planet Earths inside. Its influence extends far beyond its orbit. This gas colossus not only controls satellite motion, but acts as a kind of cosmic shield, attracting asteroids and comets that could threaten Earth. Jupiter is a world of storms, crushing hurricanes, monstrous pressure, and magnetism spanning millions of kilometers. It's impossible to imagine without the eternal Great Red Spot, incredible auroras, and 4 largest moons, each of which could be a separate planet itself. Its mass is more than 318 Earths, but if it continued gaining matter, it wouldn't grow larger. At a certain point, under gravity's action, it would simply begin compacting, turning into an even denser ball. Its gravity is 2.5 times stronger than on Earth. Composition and structure. Jupiter consists mainly of hydrogen and helium, much like the Sun. If you descended below outer clouds, a journey would begin through layers of increasingly dense gases. First, an atmosphere filled with swirls of ammonia and methane, with hurricanes extending 1,000 km/h. Further, pressure increases so much that hydrogen becomes liquid, then metallic, transforming into a substance obtainable on Earth only in laboratories under monstrous pressures. This is an ocean of metallic hydrogen tens of thousands of kilometers deep, behaving like metal and conducting electricity. This is where Jupiter's incredibly powerful magnetic field originates, extending millions of kilometers around it. What lies even deeper? Possibly a small rocky core about the size of 10 Earths. But scientists still debate. It's quite possible that due to colossal pressure, this core has already partially dissolved in liquid hydrogen. Atmospheric dynamics. Jupiter wouldn't be Jupiter without its seething atmosphere covered with characteristic bands. These light and dark zones are consequences of powerful winds moving in opposite directions at speeds up to 600 km/h. The entire planet's atmosphere is a boiling ocean of gas where constant vortices create bizarre patterns. Lightning flashes thousands of times brighter than on Earth, and pressure in lower layers compresses gas to liquid state. And of course, the Great Red Spot must be mentioned. This giant hurricane, a true veteran among storms, has raged for at least 350 years. The hurricane's diameter today is about 16,000 kilometers, several times larger than Earth. And that's even smaller than before. The spot is slowly shrinking. Scientists don't yet know if it will ever disappear completely, but this storm remains one of the most impressive phenomena in the solar system. Magnetic field. Jupiter's magnetic field is the most powerful among all planets, 20,000 times stronger than Earth's. It creates a giant magnetosphere so large that if it were visible, it would occupy more space in the sky than the moon. Jupiter is a true radiation hell. Around it rage streams of charged particles, and radiation in its vicinity is deadly even for the most protected spacecraft. That's why missions like Juno must perform complex maneuvers to avoid the most dangerous zones. The Galilean moon's Jupiter isn't just the gas giant itself, but an entire satellite system. It has more than 80 moons, but the most famous are the 4 Galilean satellites: Io, Europa, Ganymede, and Callisto. Each is a separate world with its own history and unique features. Io is volcanic hell, the most geologically active object in the solar system. Volcanoes on Io constantly erupt lava tens of kilometers high, and the surface is covered with sulfur, making the satellite bright yellow. Its internal structure heats up due to gravitational tug-of-war between Jupiter and other satellites. Europa is a world beneath ice. Its surface is covered with an ice crust several kilometers thick, but beneath it hides an ocean of liquid water. Not just any ocean. Its volume is greater than all Earth's oceans combined. On the surface are visible cracks caused by Jupiter's tidal forces, and geysers eject water jets into space. If life exists anywhere in the solar system besides Earth, Europa is one of the main candidates. Ganymede is the king of satellites, larger than the planet Mercury. It's the only moon in the solar system with its own magnetic field. Its surface is covered with ice and ancient craters, and inside possibly hides a subsurface ocean. Callisto is an ancient, crater-covered world, one of the oldest objects in the solar system, whose surface has remained virtually unchanged for billions of years. Like Ganymede, beneath its icy crust may lie a hidden ocean. Saturn, the ringed beauty. After Jupiter, our path lies further toward Saturn, a planet that truly is one of the most beautiful in the solar system. If Jupiter can be called the king among planets by size and might, then Saturn is its aristocratic counterpart, surrounded by the most stunning ring system that makes it one of a kind. Physical characteristics. Saturn is the second largest planet in the solar system. Its diameter is 120,536 kilometers, approximately 9.5 times Earth's diameter. However, despite enormous size, Saturn is the lightest planet of all. Its average density is less than water's density. This means if there were a large enough ocean, Saturn could float in it. But of course, its main feature is its magnificent rings, which made it one of the most recognizable planets in the solar system. The ring system. When we look at Saturn's photographs, the rings seem dense and continuous, like a solid disk. But this is an optical illusion. Actually, they consist of billions of particles of ice and rocks orbiting the planet. The size of these particles varies from tiniest dust specks to house-sized boulders. Ring thickness is incredibly small compared to their width, only about 10 meters on average, while their diameter exceeds 282,000 km. Essentially, it's a giant flat disk so thin that in profile it practically disappears. Scientists still debate the ring's origin. There are several hypotheses. Perhaps these are remains of a destroyed satellite that came too close to Saturn and was torn apart by its gravity. Or perhaps this is material that simply couldn't gather into a full satellite due to the planet's gravitational influence. In the rings are interesting formations, for example, the Cassini division, a huge gap about 4,800 km wide, dividing the ring into two parts. The culprit of this gap is Saturn's moon Mimas, which with its gravitational influence sweeps particles from this area. Atmospheric features. Like Jupiter, Saturn's atmosphere is a mixture of hydrogen and helium with admixtures of other gases that give clouds yellowish and golden hues. But if Jupiter's greatest attention is drawn to its red spot, Saturn has a no less mysterious structure, a hexagonal storm at the North Pole. This structure is a true scientific phenomenon. Imagine a giant hurricane 25,000 km wide having a strictly geometric shape of a regular hexagon. Inside this storm rage winds at speeds exceeding 500 km/h, and its edges remain surprisingly sharp, as if someone drew them with a ruler. Scientists still don't know why the hurricane has such a form. Titan, a world of liquid methane. Among Saturn's 83 satellites, Titan particularly stands out. This is one of the most amazing objects in the solar system. Titan is the second largest satellite after Ganymede, larger than Mercury, and the only moon with a dense atmosphere. It's precisely the atmosphere that makes it so special. If you stood on Titan's surface, the sky above you would be orange-yellow, and around would spread plains covered with frozen hydrocarbons. And the strangest thing is that on Titan it rains, not water, but liquid methane and ethane. Temperature here is 180 degrees, so water in this world is solid as rock, while rivers, lakes, and seas consist of hydrocarbons that remain liquid at such temperatures. This world amazingly resembles Earth. It has seasons, clouds, precipitation, and its rivers and lakes change depending on time of year. But most interesting is that deep beneath Titan's surface may hide an ocean of liquid water. If so, conditions suitable for life may exist there. Enceladus, icy geysers. If Titan attracts attention with its dense atmosphere, another Saturn satellite, Enceladus, amazes with its geysers. Enceladus is a small world. Its diameter is only 500 kilometers, but it turned out to be incredibly active. The Cassini spacecraft discovered that from Enceladus's south pole, water jets eject into space, forming entire clouds. These geysers are so powerful that from their particles formed one of Saturn's rings. Beneath Enceladus's surface hides an ocean of liquid water, and in its composition are found organic molecules and traces of chemical reactions that could become an energy source for life. This makes Enceladus, alongside Europa, one of the main candidates for searching for extraterrestrial life in the solar system. Uranus, the tilted giant. After the journey through Saturn's domains, our path continues further into the solar system's depths, to where the world of ice giants begins. Uranus is the seventh planet from the Sun. Though its size is inferior to Jupiter and Saturn, this planet amazes with its uniqueness. It's as if it violates all rules. Blue, mysterious, rotating on its side, surrounded by rings and satellites with amazing reliefs. Physical characteristics. Like Jupiter and Saturn, Uranus is a gas giant, but it has an important difference. If the two largest worlds of our system consist mainly of hydrogen and helium, Uranus and its neighbor Neptune belong to another category: ice giants. What does this mean? The fact is that Uranus's composition contains far more heavy elements such as water, ammonia, and methane. Instead of hot metallic hydrogen like Jupiter, in Uranus's depths extends a huge icy layer of these substances. The sideways rotation. Uranus's most amazing feature is its unusual rotation. Unlike all other planets that spin more or less vertically, Uranus is tilted 98 degrees. This means it literally rolls along its orbit, and its poles alternately face directly toward the Sun, then go into complete darkness. This makes seasonal change on Uranus the most extreme in the solar system. If on Earth winter and summer change every 6 months, on Uranus one pole faces the Sun for 42 years straight, then comes 42 years of night. Why did this happen? Scientists believe that in early formation stages, a huge object crashed into Uranus, possibly a planet the size of Earth. This collision changed its tilt, and now Uranus rotates completely differently than all others. Atmosphere and climate. Though Uranus looks like a calm blue ball, in fact its atmosphere is extremely dynamic. It consists mainly of hydrogen, helium, and 2% methane. It's precisely methane that makes Uranus blue because it absorbs red light while reflecting blue and green. On Uranus blow the strongest winds, reaching 900 km/h, even faster than hurricanes on Earth. Sometimes giant storms appear in the atmosphere, difficult to see because the cloud layer is very dense. Rings and moons. Though rings are associated with Saturn, Uranus has them too. They're much thinner and darker than their neighbors, consisting of particles that poorly reflect light. But the main wonders hide among its 27 satellites. The most unusual is Miranda. This satellite looks as if it were assembled from pieces. Across its entire surface run giant fractures, ledges, chasms. Some of Miranda's canyons are deeper than the Grand Canyon on Earth. Scientists suggest that once Miranda was destroyed by a powerful collision, but then its fragments gathered together again, forming this chaotic world. Exploration. Currently, the only spacecraft that ever visited Uranus is Voyager 2. In 1986, it flew past the planet, transmitting the first and only close-up images. Since then, no apparatus has visited Uranus again, but scientists are planning a new mission. Perhaps in the 2030s, NASA will send a probe that can study the atmosphere, satellites, and internal structure of the planet in detail. Neptune, the wind-swept world. After icy and mysterious Uranus, our journey reaches the last of the known giants of the solar system, Neptune. This planet is the farthest, the windiest, and perhaps the most mysterious. Even today, despite modern telescopes and computer models, Neptune remains one of the least studied planets. Physical characteristics. At first glance, it resembles Uranus, the same bluish ball hidden under a cloud layer. But look closer, and the difference becomes obvious. If Uranus is a quiet and cold world, Neptune is a violent storm giant where the most powerful hurricanes in the solar system rage. This planet is the true master of cosmic winds, and its history is full of mysteries. Neptune is an ice giant like Uranus, but its atmosphere is more dynamic and much more active. It consists mainly of hydrogen, helium, and methane, giving it the same bluish-blue color as Uranus. But most importantly, the winds. The fastest winds. In Neptune's atmosphere blow the strongest hurricanes in the solar system. Wind speed here reaches 2,400 km/h, faster than the speed of sound in Earth's air, and 3 times more powerful than the most destructive hurricanes on our planet. Scientists still don't understand how Neptune maintains such a turbulent atmosphere. The planet receives only 1/900th the sunlight compared to Jupiter, and its upper layers seem cold and calm. But deeper rages a true hell of storms and tornadoes moving at enormous speed. The Great Dark Spot. Neptune also has its own giant hurricane, the Great Dark Spot. When Voyager 2 first transmitted Neptune's image in 1989, scientists saw a huge dark spot resembling Jupiter's storm. It extended 8,000 kilometers, and wind speed inside the hurricane reached 2,400 km/h. But when, several years later, astronomers again aimed the Hubble telescope at Neptune, the dark spot had disappeared. It simply dissipated. Later, new dark spots were found, other giant hurricanes that appear and disappear in Neptune's atmosphere every 5 to 10 years. This makes it the only planet in the solar system where huge storms don't exist for centuries, but come and go within counted decades. Internal structure. Like Uranus, Neptune has no clear surface. If someone tried landing on it, they'd simply sink deeper and deeper into gas layers until pressure crushed them. Unlike gas giants Jupiter and Saturn, Neptune has more ice and heavy compounds such as water, ammonia, and methane. Beneath the dense atmosphere hides a thick layer of icy mantle, probably consisting of water ice, frozen ammonia, and other compounds. But beneath this thickness hides a core similar to Earth, hot, dense, consisting of rocks and metals. Temperature in Neptune's center may reach 7,000 degrees. It's precisely this hot core that helps maintain powerful winds and atmospheric activity, because Neptune radiates twice as much heat as it receives from the sun. Triton, the captured moon. Among Neptune's 14 satellites, Triton stands apart. This is the planet's largest satellite and one of the strangest objects in the solar system. Triton's main feature: it rotates in the wrong direction. Unlike most satellites that move in the same direction as the planet, Triton rotates in the opposite direction. This means that once it didn't belong to Neptune, but was captured by its gravity from the Kuiper Belt, an area full of frozen objects beyond Neptune's orbit. But the strangeness doesn't end there. Triton's surface is covered with nitrogen ice, and its temperature is 235 degrees, making it one of the coldest places in the solar system. However, most amazing are the ice geysers. Voyager 2 discovered on Triton giant nitrogen jets ejected from the surface. This means deep inside the satellite is a heat source warming the ice and causing it to evaporate. Some scientists believe beneath Triton's icy crust may hide an ocean of liquid water, like on Europa and Enceladus. Future exploration currently, the only apparatus that ever visited Neptune, is Voyager 2. Since then, no probe has been sent to Neptune, but in recent years, astronomers have been discussing the possibility of a new mission. One project is Neptune Odyssey, which could launch an orbital apparatus to the planet and study it in detail. NASA is also considering the Trident mission, which could go to Triton and test the hypothesis of a sub-ice ocean. But such missions will take decades. Even if a probe is sent in coming years, it will reach Neptune only in the 2040s. Beyond the planets. Small bodies. Our journey through the solar system's planets has concluded, but the system itself doesn't end there. Beyond Neptune stretches the Kuiper Belt, which hides thousands of icy worlds such as Pluto, Haumea, Makemake, and other dwarf planets. We've covered all 8 planets, But between them and beyond their limits extends a whole world of small bodies, asteroids, comets, dwarf planets, and meteorites. The asteroid belt. When astronomers first began systematically observing the sky, they expected to find another planet between Mars and Jupiter. After all, by dynamics laws, another large world should have been located precisely there. But instead of one planet, they discovered an entire asteroid belt, a zone filled with millions of small objects that never managed to form a full planet due to Jupiter's gravitational influence. Asteroids come in different sizes, from giants like Vesta, approximately 525 kilometers in diameter, to tiny fragments barely reaching several meters. They consist of metals, silicates, carbon compounds, and some even contain water. But beyond scientific value, asteroids carry a real threat to Earth. We know that 66 million years ago, one of them fell on our planet, causing the dinosaurs' extinction. Today, astronomers carefully track potentially dangerous asteroids capable of crossing Earth's orbit, dwarf planets and the Kuiper Belt. For a long time, Pluto was considered the solar system's 9th planet, but in 2006, astronomers changed classification, assigning it to dwarf planets. This caused heated debates, because for many, Pluto remained a full planet. But why was it demoted? The fact is, it doesn't dominate its orbit. Around it are other objects such as Haumea, Makemake, and Eris, which also could claim planet status. All are located in the Kuiper Belt, a huge area beyond Neptune filled with icy bodies. But despite this, Pluto remains a very interesting object in the solar system. It has 5 satellites, the largest of which, Charon, is so large compared to Pluto that they form a binary system, rotating around a common center of mass. Its surface is covered with icy plains and cryovolcanoes, from which instead of lava flows liquid nitrogen and methane. Pluto's atmosphere consists of nitrogen, methane, and carbon monoxide, forming a blue haze resembling Earth's sky. When the New Horizons probe flew past Pluto in 2015, it transmitted images that amazed scientists. This small world turned out to be far more complex and active than expected. Comets, dirty snowballs. If asteroids consist mainly of rock and metal, comets are the solar system's dirty snowballs. They contain water, frozen gases, and organic molecules. When they approach the sun, they begin melting, forming a tail. This tail always points in the direction opposite the sun because it's formed by solar wind blowing away evaporating substances. Comets come from 2 areas: the Kuiper Belt, the nearest source of short-period comets such as the famous Halley's Comet, returning every 76 years, and also the Oort cloud, a huge sphere at the solar system's edge from which long-period comets arrive, such as Comet Hale-Bopp. Comets played a key role in Earth's history. Some scientists believe they brought water to our planet and possibly even organic molecules necessary for life. Meteorites, messengers from space. What about meteorites? These are small fragments of asteroids or comets that fall to Earth. Most burn up in the atmosphere, creating the beautiful effect of a falling star. But some reach the surface. The most famous in recent times is the Chelyabinsk meteorite, which entered the atmosphere in 2013, causing a shockwave that shattered thousands of windows in the city. Conclusion: our place in the cosmos. Today we've traveled from the sun's blazing heart to the icy boundaries of the heliosphere. We've flown over Mercury's craters, through Venus's clouds, gazed at Earth from light minutes distance, peered at Mars, past Jupiter's storms, Saturn's ringed worlds, Uranus's tilted horizons, and distant blue Neptune. We've encountered comets, asteroid belts, Pluto's forgotten orbits. We've looked back and seen, these aren't just planets. This is matter's history. These are our roots, and so our journey approaches its end. Everything we've seen was once dust, and this dust became stars, planets, and us. We are children of the sun. We carry in our bones calcium born in stars' cores. We breathe oxygen squeezed from ancient solar processes. We think with a brain composed of carbon formed billions of years ago in other galaxies. The cosmos isn't somewhere out there. It's inside us. And as you close your eyes, imagine, outside the window is night. But this isn't just darkness. This is the universe. Perhaps right now, from the other side of the galaxy, someone looks at the sun as a distant star. Perhaps someone dreams of touching Saturn's rings as we dream of Andromeda's stars. Perhaps everything repeats, or perhaps everything is only beginning. And if tomorrow you look at the sky, maybe you'll already know where your home is. Among all those distant stars, among all those impossible distances, there's a point where soft, steady light burns. It's called the sun, and around it flies Earth, and on it, you. Thank you for spending this night with us. May you dream of the sky, and may in your dream you fly again through the solar system, slowly, freely, and calmly, until our next meetings and nocturnal wanderings.